Hi class, in this lesson we're going to take a look at section 5.3, and we're going to be talking about calculating in other bases and learning how to do with things like base 5, our current base 10, and all sorts of other bases. To understand how bases work, we have to really clearly understand our own counting of base 10, how it works. And what we should be able to come up with is that the zeros represents our ones or units, and so here we've got 0 ones, and the 1 represents 10. So we've got one group of 10 and then 0 groups of ones, and so it's just kind of grouping. And so what we're going to be taking a look here is different bases. This is base B, so we can change the base to be any base. If this, whatever base this is, we got 1 of whatever base it is, and we've got 0 of our units. Just like Babylonians, we had 0, this would be 0 ones, and this would be one group of 60. So the number 10 for Babylonians represents 60, if you will, if we write it this way. So let's count in base 5. So obviously we've got 1, 2, 3, 4, and then 5 is one group of 5. So actually I have to write it as 10. And then we write this little 5 right here to represent that we're talking about base 5. So again, 1, 2, 3, 4, 10. Now that may feel awkward, but the 1 represents it's saying one group of 5. Okay, so let's take a look at 24. Actually, what we can do first, let me further this by adding on. So if I want to count 6, so we'll say 6, 7, 8, 9, 10 for base 5. This would be 1, 1, 1, 2, 1, 3, 1, 4, and then we'd say 2, 0, base 5. Let's probably write the 5 after each one of these. So this is one group of 5 and another 1. One group of 5 and 2 ones. One group of 5 and 3 ones. One group of 5 and 4 ones. And then this is saying 2 groups of 5. So this is how you would count in base 5. So this number here, 24 base 5, is actually just saying you've got 2 groups of 5. So 2 groups of 5, and then plus 4 ones. So in other words, we've got 10 and 4, so it's just 14. So that is how you would count that in base 5. Okay, so let's take a look at counting further with base 5. So as you can see here, it goes all the way up to 44 base 5. And then it gets really weird because we can't just say 5, because 5 doesn't work. It looks like we would know if we have it in the 1 or the groups of 5's place if you just write a 5. So what we do is we actually make it, the next number would be 100 base 5. In other words, you're saying you've got 10 groups of 5. Okay, so as soon as we got there, hopefully you're following what I'm saying here, that I can't just say 45 5's, because it would say you would put a 5 over here, but then you would know you can't go 4D, so it gets really goofy there. Let me draw that out a little bit more. So I can't just say 45, because this is 5 groups. You need to add it over here, so you can't say 5, 0, because it won't work for us to have a 0 place, and we can't just say 5. And so the reason why you can't say 5 zeros is you can't jump from 45 and go to 50. So obviously something's going on here, so that's why we have to bounce it one more over and say, all right, we've got one group of 10 5s to represent 50. So 10 groups of 5 to represent 50. Okay. All right, so moving on, we're going to take a look at base 8. And the way base 8 goes is you count 1, 2, 3, 4, 5, 6, 7, and then 8 is saying we've got one group of 8. And then 11 is one group of 8 and 1, which is 9. One group of 8 and 2 is 10. And then so on down the list, all the way over here where you get up to 77, and then 78, 78, and then we add over here and we've got one group of. Now the reason why 64 is here and why it looks like 100 is because what you're saying is we've got 8 groups of 8. So I would have had an 8 right here, and so what we're saying is we have 8 groups of that, so we have one group of 8 eights, and that's why it's 100 here. So 8 times 8 is 64, and then you would keep adding again. Okay, so let's take a look at how this plays out for us when we have groups that are larger than base 10. So larger than base 10 gives us problems because up here in base 5 and base 8, we can count up just like we normally do, and then as soon as we get to that newer, smaller than 10 number, we just call that 10. And we're saying we have one group of 8. And then over here, when you've got 16, you've got 2 groups of 8. All the way up to 8 groups of 8 is we have to add our extra 1 for 100. So down here, let's say I wanted a base of 16. So this is a base of 16 here. The reason why I know it's base 16 is because it's got the 10 and the 16. And that means I've got one group of 16 here. So as you can see, I'm counting 1 through 9, and then I can't say 10 because 10 has to be wherever the base is. So notice up here when it's base 8, and earlier on the last slide is base 5, the 10 is always whatever your base is. So 1, 2, 3, and then what you have to do is use some other symbols. It doesn't have to be letters, it can be. But we use A, B, C, D, E, F, and then as soon as it got to 16, we went and wrote 10. And then we'd have to keep counting like that as we move forward. So we go 1, 2, 3, all the way up to 31 would be our F, and then we hit 32, which is 2 groups of 16. And so each time you'd have F, and you would get up to here. It gets really confusing and complicated, but it is manageable in an ugly algebra way. So in designing digital devices such as satellite radios, MP3 players, we use base 2, binary. Maybe you've heard of binary before. Maybe you've taken a coding class. And this system uses only zeros and ones. Maybe you've seen the movie Matrix, and you've seen the numbers scrolling off the green numbers on the screen, the computer screen. Those are all zeros and one, and what they're doing is they're looking into the binary system of the actual computer. It's why that was cool for people to watch. And so the way that this goes is you've got just 2 numbers. It's 1, and then 2 is 10. And then 1, 1 is one group of 2s, and 1, so it's 3. And then 4 is, you have 2 groups of 2, and no other one, so that's 4. So it's 2 groups of 2 is 4. And then you have 5 is 2 groups of 2, and then 1. And then 6 is 2 groups of 2, and another 2, so that's 6. So that's how these numbers go in binary. So it can, hopefully that I'm saying it clear enough that you're following. Where 8, this is 4 groups of 2. 9, you're saying you have 4 groups of 2 and 1. Okay, so expanded notation works the same in non-base 10 systems, very much the way that works in our current Hindu-Arabic system. For example, we write the number 23, so 2304, base 5, in expanded notation like this. You start here on the far right, and you're saying you've got 4 ones. So this is just our units place. And then we're saying we have 0 groups of 5s. 5 to the 1s, just 5s. And then this next one would be 5 squareds. So this is our 1s place, our 5s place. And again, the reason I know that is because this little 5 down here, this subscript 5, is telling me it's base 5. Like I mentioned it earlier, I hope I did. And so then our 3 is saying we've got 3 groups of 5 5s. Another 5 groups of 5, so 5 squared. So 3 groups of those. So that looks like 3 times 5 squared. And then last we've got, this would be groups of 5 times 5 times 5, so 5 to the third. So just like we were doing in the last lesson where we're counting expanded form with base 10, we start with this furthest to the right is our power, our base to the 0. This is always 5, or whatever your base is, to the 1. This is your base to the second, and this is your base to the third. And so you take each one of these numbers and just multiply it by that number, and then add the result in expanded form would give you the actual number in our Hindu-Arabic system. Okay, so, and on this one, it doesn't actually ask us to write it or to calculate it. We're just asked to write it in expanded form. Okay, so let's convert this to actual decimals. So notice the difference on the directions. This one just says write it in expanded notation, and this one's saying actually convert it to decimal notation. So to get it to decimal, you have to expand it first. And this is what it would look like expanded, just like the directions I said a moment ago. We take 2 times 5 to the 0, 0 times 5 to the 1, 3 times 5 to the second, and 4 times 5 to the third. And then if you just take your calculator and just throw that in there the way it's written, you have to be careful because it depends on what kind of calculator you're using. If you're using a phone calculator, if you type this in the way that it's written, you're going to struggle. But if you have a scientific calculator or a graphing calculator, it will work just fine. But if you have a phone calculator, you want to do this guy first, and then do this right here. So basically, you're getting the 500, you're getting the 75, you're getting the 0, and then you're getting the 2 first. Once you get all that, then you want to go ahead and just add it together at the end to get you 577. Okay. So again, be careful on your calculator for dealing with order of operations, which we'll actually talk about in a following lesson here. But you want to make sure that your order tab ranks. So don't just type this in exactly the way that it is, otherwise it's going to add the 3 to the 500 before you times it by 5 squared, and you're going to get a very large number. So make sure you're doing each individual part first to get these numbers here, and then add at the end. So just following our order of operations.